Uncertainty can be determined in various ways. The best way is to use historical data. So what is history tells us about the duration of activities. And if you keep track of historical data, you can actually determine what the minimum, most likely, which will be the mode or maximum duration is of a certain activity. The other way is by talking to experts. When you're talking to experts, they will tend to have a bias. They can either be very conservative in their estimate, realistic, or aggressive. It's therefore a good practice to take into account these biases when you're making your Primavera schedule for simulation. So you can adjust for the type of bias that you're getting. For instance, if somebody you know gives you an estimate and you think the general consensus is that the estimate is very conservative, you can set your distribution, let's say triangular distribution, with a minimum of 50%, and most likely of 100%, and a maximum of 100%. For conservative, 75, 100, and 105%. So depending on the person you're asking the estimate for, try to imagine or try to determine what is their bias. Are they very conservative? Are they conservative, realistic, aggressive, or very aggressive? When you know that, you can adjust their estimates to get a more realistic picture. So in Primavera, we can actually apply some settings so we can automate the estimates and determine whether somebody is very conservative, or very aggressive. The steps are as follows. First, we go to Plan, and we're going to create a custom field. So we go down to Task User Fields, and you see here are all the user fields, and we're just going to create a new one. And I already created this. It's called Estimate. The type, we're going to set this to Code. And then under Code here, we're going to set the code VC to very conservative, C to conservative, R to realistic, A to aggressive, and VA to very aggressive. So this is a custom code we're going to be using later. Next, we're going to go to Risk, Templated Quick Risk. So here we're going to set our field that we just created, which is Estimate. And we're going to say, well, if the value is very conservative, we want a triangular distribution of 50%, 100%, and 100%. If the estimate is conservative, we're going to set it to 75%, 100%, and 105%. If the estimate is realistic, we're going to set it to 80%, 100%, and 120%. If the estimate is aggressive, we're going to set it to 95%, 100%, and 125%. Finally, when the estimate is very aggressive, we're going to set it to 100, 100, and 160. So what it does when somebody gives a very aggressive estimate, it puts more value and more weight to the minimum and most likely duration. And the chances of reaching this max value of 160% is going to get smaller. Remember, it's a triangular distribution. So just going to hit apply template and then save and exit. So for estimating purposes, we need to actually include the column of estimate. So for that, we right click, format, go to user fields, and we find the one that we just created, which is estimate. I'm going to move it over, and I actually want it right next to the remaining duration because this is where my estimate is. And then apply OK. So once you get your information for all these activities, it's up to you to determine whether this is going to be conservative or aggressive. So let's just say this site preparation is very aggressive. This excavation is also aggressive. This installation on the wall line is realistic for the conduit as well. It's very conservative for the following concrete work. And then the backfill is going to be conservative. So now we've applied these estimates, and I'm just going to clear out the old uncertainty that we determined. And now let's run the templated quick risk based on the information we put in. So this is the information we put in. And the system is going to look at these values and apply this uncertainty to the activity. So say apply template. It's been applied to a task. OK. Save and exit. And as you can see, now all activities have been adjusted according to the templated quick risk. And that is based on whether the estimator of the duration is estimating aggressively or realistic or very conservative. If you look at the distribution triangles, let's look at this one, for instance. So this 18 days is considered very conservative. If you look at the distribution, you see that the chance during a simulation that this duration is going to be smaller than this 18 days, which is a very conservative estimate, is not that big. Most of the iterations will fall close to that 18 days. And this is how we adjust for estimating biases. So now we have determined the uncertainty or applied uncertainty for a duration. Let's see and determine uncertainty for resources. So there's a couple of ways we can do this. On a high level, we're going to plan resources, and we get back into our resource schedule. And these resources, most of them are applied at $1, except for the day rate for the engineer and the day rate for the superintendent. Now, it is possible that when we are creating the schedule, that the day rate for this engineer is not 100% certain yet. So we can actually tell the system to apply uncertainty. So right now you can see the cost uncertainty is set to none. We can change that, and we can change it to a distribution. So the standard distribution is 25% up and 25% down. So that's what the system automatically does. But we can change this. We can say, well, most likely it's $1,000, but we could perhaps get it as cheap as $800 a day. But it can also be $1,100 a day. So now every time we apply an engineer to our schedule, we'll get this uncertainty. So I'm going to just close this out. Besides applying resource uncertainty on the highest level, under your resources, The other way is you can apply uncertainty for specific tasks. So let's look at form concrete footings, this task, and look at the resources that have been applied. As you can see, there is iron workers, rough carpenter, operator, and a crane. Let's say that some of these expenses on this specific activity are uncertain. We go to risk and uncertainty, and here you see the resources, and right now there's no uncertainty applied to them, but we can actually activate this. So I can choose, for instance, iron worker, and I'm seeing that the most likely is 333 units per period. When you are changing this, leave the most likely as it is and only change the minimum and maximum. So let's change this to 300 and change the maximum to 450. And for the crane, I'm expecting some uncertainty as well. I don't think it's going to be 500, it's going to be 600, and it could go up to 1,000. So now just for this activity and these resources for this specific activity, I've applied uncertainty. So let's run the analysis again. So if I go to cost, I see that my deterministic value of 267,525, we can see that nothing at all changed, which is very interesting. So let's look at the effects of these estimates being aggressive or very conservative or conservative. So let's leave it as is and run the risk simulation. So as you can see, with the current situation, our deterministic value of 267 has a confidence level of 94%. Now, what happens if we say, okay, all these estimates are conservative? So we can either change them like this, or we can, just like in Excel, hold Shift, select the last one, and then Control D, copy down. Nothing has changed here. We have to run the templated quick risk again. Apply template. Okay, and you see the values have now changed. So I'm going to save and exit this, and then let's run the simulation again. And now our deterministic value has gone up to 96%. Let's close this out. Now, what if we set this to aggressive? So I'm changing all these values to aggressive. Apply the template. Save and exit. Let's run the simulation again. And now you see a whole different picture. My deterministic value has dropped to 1% probability. So here you can see the differences in the impact of determining whether your estimator is going to be conservative or aggressive when he gives you the duration estimates.